Hey, good morning, everyone. Hope you all had a good weekend. Wanted to start off by just taking a quick look at our schedule to see where we are. Right now we are on parallel and perpendicular lines. We'll finish that up today, and then we will get into functions and function notation, applications of linear functions, hopefully be able to get through all this. And then when we come back, when we come back on Wednesday or a Thursday, we will do more applications, and then we can start talking about exam 2, which will take place, let's see, a week from today. So next Tuesday, we'll have an exam. I'll have a review available to you by Wednesday. That way you'll have an idea of what to expect on that exam. And we'll run the exam exactly the way we ran exam 1. So are there any questions before I begin?
I had a question on the homework.
Okay.
It was on page 55, number 9.
Okay, let me bring that up. Okay, so are we looking at the same thing? Or are you saying page 15?
Oh wait, maybe it was number 4, maybe not number that.
Okay.
Oh yes, I'm sorry, number 9, sorry.
Number 9 on 57? The one with the fractions?
Yes.
Okay, let's go ahead and do that one then. Oops. Let me move this to a different window so I can see it. So we have 1/2 y equals -1/6 x plus 3/2. And you're asked to sketch this line using, I told you to use whichever method you wanted to. So what method did you want me to do here?
I feel like usually if I saw it set up like this, I would use the one, the slope intercept method.
Okay, so your goal here then is to try and get this to look like y equals some number in front of x plus some number by itself, right? Okay, well, we almost have that. We have 1/2 y. We've got a number in front of x, and we've got a number by itself. The problem that we have is the 1/2. That needs to be gone. Because in the original, well, in the form we're looking for, our goal, our y is by itself. So really there's like a 1 in front of that y. Is that all right, Carolyn?
Yeah.
Okay, so if I have a 1/2 in front of the y, what could I do to both sides of the equation to make that a 1 instead of a 1/2?
You divide it?
Okay, so I could divide by 1/2. Is that what you mean?
Yes.
Okay, yeah, that will work. We could divide everything by 1/2. Now, if I do that, I think it's going to be a little bit confusing because you're going to start dividing fractions by fractions, right? Like if I said divide that by 1/2, that means you have to divide everything on both sides by 1/2. Now we can do that, okay? And let me just do it, all right? And then I'll show you just a different approach afterward. If I do this 1/2 over 1/2, that becomes a 1. And so now you have y equals, now what we need to figure out is what is 1/6 divided by 1/2. So if you need to, you can do that on the side. What's 1/6 divided by 1/2? And then remember the keep dot flip?
Yeah.
We can go -1/6 dot and then flip. And then just multiply straight across. -1 times 2 is -2. 6 times 1 is 6. And then that fraction reduces to be 1/3. So now we have a -1/3, I should have said -1/3, x. And then we now need to do this part right here, which is going to be 3/2 divided by 1/2. And again, keep dot flip, 3/2 times 2 over 1. Multiply straight across, you get 6 over 2, which equals 3. So this will become +3. Does that all make sense, Carolyn, everyone?
Yes.
Yeah, okay, so now we have it. We have that M, right? That's our M. And then we have this thing right here is our B. So we go ahead and graph. And we always start out with the B. And the B is always the y-intercept. So I'm going to go up to 3. And I will put a dot here. And then from that point, I need to use the slope. The slope is -1/3. So my rise over run is what I'm looking at. And if I have a negative as my rise, that means I actually go down 1. And then the 3 on the bottom means I go to the right 3. So I go down 1, right, 1, 2, 3, I put a dot. And once I have the 2 points, I draw a straight line through them. Does that make sense?
Yes, makes sense.
Okay. So I think doing it that way, I agree, works. Let me just show you a slightly different approach. You're going to get exactly the same answer, but maybe some students in the class would prefer to do it this way. So you said let's divide by 1/2. Well, dividing by 1/2 is the same as multiplying by the reciprocal of 1/2, which is just 1/2 flipped over, which is 2. So you could also just multiply the left side of this by 2 and the right side of this by 2. And what happens is these two come together. That's really like 2/1 times 1/2. That just gives you a 1. So that gives you your y. And then on the right, you distribute this through. And when you do that, you do the 2 times, you're doing 2 times -1/6. I'm not going to show the work, but you get -1/3. And then you get 2 times the other fraction, 3/2. And that will give you 3. So you wind up with exactly the same thing, -1/3 x plus 3. Do you see that one? Do you see how that's just slightly different? It's the exact same sort of, well, it's not the exact same work, but it's gets you to the exact same place.
Yes, I do. Thank you.
Okay. Were there any other questions over the homework? No? Okay, well, in that case, let's continue from last time. Remember last time we were talking about parallel lines. We said 2 lines, if you compare 2 lines together, we can say that they're parallel if they have the same slope, right? The same slope, that's what makes 2 lines parallel. And then we said to be perpendicular, which means the lines would intersect at a perfect like cross, that the slopes would have to be opposite reciprocals. And so that means they have to be, one would have to be positive, the other one would have to be negative, and that they would have to be reciprocals of one another. And so I gave an example here where we had a line 1, where the slope was 4. So to be perpendicular, you have to take that 4, you have to change it, make it the opposite of 4, which is -4, and then you have to flip it. Reciprocal means flip it, and it becomes 1/-4, -1/4. So these 2 lines would be perpendicular. All right. So let me give you, let's look at a problem out of the packet that would be somewhat like this. All right, so let me figure out where I am here. No, I went too far. Sorry. There we go. That's what I wanted. Okay. So let's take a look at, we're going to get to parallel and perpendicular, but there's one thing I didn't do. I told you on the homework to skip over, and that is, we know if someone gives us an equation of a line, we should be able to find the slope by getting it into that form y = mx + b. But what if someone gives us just 2 points on a line? and they ask us to find the slope. All right, so I'm going to take, let me take this first example here. And get to today's notes. So let's find the slope of the line through these points. Okay, those are the instructions for this problem. So we don't need to do this, but I'm going to. I'm just going to graph this. And so let me graph the first point. I go out to the right 6, 1, 2, 3, 4, 5, 6, and I go down 2 and have a point there. Then the other point, I go out to the right 8 and I go down 3, which is here. And so I have a line through those 2 points. And what the question is, and the problem is, what is M, right? What's the slope of this line? Now, to do this problem, what we're going to try and figure out is to get from one point to the next, we need to ask ourselves, what's our rise? And then we also need to figure out what the run is. Because remember, by definition, the slope is always the rise over the run. Now, we could just look at this problem and try and think about what it is, but there's a formula that we can use, all right? And the formula basically says that to figure out the rise, what you need to do is take the difference of the y coordinates of the points. So I'm going to write it this way, y2 minus y1. And then you want to divide that by the run, which is left and right, and that would be the difference in the x coordinates, which I will call x2 minus x1. So that's a formula, all right? So what we're saying is that this first point, okay, the first point we have, we're going to call the x coordinate x1, and we're going to call the y coordinate y1. And then the second point that we have, we're going to call the x coordinate x2 and the y coordinate y2. And if you do that, then all you have to do is plug the numbers into the formula and you have your slope. So for us, we're going to take y2. y2 for us is -3. We're going to subtract from that y1. y1 for us is -2. Be careful there. You'll see how I had to put the minus here for the formula, but I also had a negative on the 2. So you're going to have a double negative there, so be careful. Over x2, which is 8, and take away from that x1, which is 6. And then you just have to calculate what that is. So this becomes -3. Minus minus becomes +2. And then on the bottom, I can do 8 minus 6. That's just 2. And then you just compute -3 plus 2 is -1. And then over 2. So your slope is -1/2. So this is just arithmetic, but you have to be careful with your signs and be careful with making sure you get the right order. It's always y2 minus y1 over x2 minus x1. If you flip any of those, it's going to be off. And we can just double check our answer. Does it make sense? So when we go from one point to the next, right? When we go from one point to the next, are we going down 1 and to the right 2? So was it down 1 and then right 2? It seems right, yeah? Okay, let's do one more of these. Let's do one with a fraction. How about that? Let's do number 20. Okay, so same thing. I would start this problem off and I would be like, okay, I need to label these. This I'm going to call x1, this one y1. This is going to be x2 and y2. And then to calculate the slope, all I need to do is take y2, subtract y1, and then x2 minus x1. Are there any questions? Now it's just plugging in. So y2 for us is -4/7. We're going to subtract from that y1, which is 4/5. all of that will be divided by x2, which is 1/2, minus 1. Now, the thing that's going to kind of suck about this problem is you've got to subtract fractions. And we did this in the very beginning of this class, right? We added and subtracted fractions. So you have to do this here. All right, so I'm going to start with the numerator. I'm going to try and figure out what this is first. And to do that, I'm going to do that little cross thing that I taught you all. Remember that little cross thing on how to add fractions together or subtract fractions? I'm going to go here times here. So I multiply 5 times -4, that gives me -20. I'm putting a minus sign because of the minus here. Now I'm doing 7 times 4, which is 28. And I divide that by what? What do I do on the bottom to get the bottom one?
Multiply 7 times 5.
7 times 5. So you do 7 times 5, that gives you 35. Now all of that is going to be divided by this one on the bottom. Now this one on the bottom is the same thing. You just need to rewrite the 1 as 1/1. That way you can do the cross thing again. So you go 1 times 1, that's 1, minus 2 times 1, which is 2, over 2 times 1, which is 2. Now, I know that looks nasty, but that's the way it is. We just need to do a little bit of arithmetic now. We do -20 take away 28. It's -48 over 35 over, and then 1 take away 2 is -1 over 2. And now we're finally to a point where we have a fraction divided by a fraction. So we have -48 over 35 divided by -1 over 2. So we'll keep dot flip, keep it, dot it, flip it. And now we go and multiply straight across. So I'm getting a -96 over a -35. The only thing I could do now is just reduce that or change it. Negative over negative is positive, so I can just change my answer to a positive answer. And this is my slope. That's a weird slope, right? I mean, it looks like we're wrong maybe, but it's right. So this is saying that on this line, to get from one point to the next point, you have to rise by 96 and run by 35. That's what we figured out. Any questions here on finding the slope given 2 points? You okay? Okay. So now let's talk about the parallel and perpendicular, which is picking up from last time. So we'll just do this number 23. I think this is a good problem to start with. Okay, use the following equations to answer the following. So they give us two lines. Line 1 is y equals -2/5 x plus 5, and the second line is 2x plus 5y equals 15. First question, find the slope from line 1. All right, let's see. Let me call on somebody today. How about Anastasia? Is Anastasia here this morning?
Yes, I'm getting ready for work.
Okay. Can you tell me what the slope of that line is, or?
Yeah, for line 1 or 2?
1.
For 1, I want to say the 2 over the 5, -2/5.
Yes, -2/5. Now, what Anastasia is seeing here is that line 1 is already in the form y equals mx plus b. It's very important that we understand that the only reason that she could say that the slope was -2/5 is because it looks like y equals mx plus b. Does everyone see that? So the answer to part A is pretty straightforward. And that is correct. Good job. Now, how about Tatiana? Tatiana, how about for part B? Find the slope of the line for part B, or for line 2. So is Tatiana here?
I'm here.
Okay. So what's different here with this line 2?
We're gonna have to find it.
Yeah, we're going to have to do some work, aren't we? Because it is not in the form y equals mx plus b. So Tatiana, what would you do first if you were going to try and get y by itself?
Can I do minus 2x on
Exactly.
both sides?
Yep. Okay, so the first thing Tatiana is saying, okay, we want to get this 5y by itself first. So Tatiana is saying, let's subtract 2x on both sides of the equation. Perfect. So this will leave us a 5y on the left. On the right-hand side, I have 15 take away 2x. I'm actually going to write that this way, 2x plus 15. And the only reason I'm doing it that way is because in the form y equals mx plus b, the x term is always in front of the number. So that's why I wrote it that way. Okay, good. How about Jesus? Is Jesus here?
Yes, sir.
Okay, so what now? We're trying to get y by itself.
Divide 5y by 5.
Yep,
And then,
do that everywhere, right? Both sides?
yeah.
So 5 here and 5 here. Good. So the 5's go away. We get y equals, now we have negative 2/5 in front of x, and then 15 divided by 5 is 3. Okay, Jesus, can you now say that that's in the form y equals mx plus b?
Yes.
Okay, so can you tell me what the slope is then?
Negative 2 over 5x.
Negative 2 over 5. So it's always just the number. You can ignore the x, okay? So the slope is just negative 2/5. Good. All right. Next up is Lauren. So Lauren,
Yes, I'm here.
okay, what about C?
Their slopes are the same.
Yep, and what does that mean?
They're parallel.
They're parallel. Good, exactly. Okay, what can we say about their slopes? The slopes are the same. You could say same, you could say equal. Therefore, they are parallel. Okay. Anyone have a question on that? What if the slope of the second line, instead of being negative 2/5, what if it had turned out to be positive 2/5 instead? Then the answer to part C would be what? What would it be?
That'll be not perpendicular. Wouldn't it just be like nothing, like undefined?
Exactly. It would be, so if they're not exactly the same, right, then they're not parallel. To be perpendicular, they have to be different in sign, but they also have to be reciprocals. So 2 over 5 means that these lines would be neither parallel nor perpendicular. Now, what if the slope, instead of being 2/5, was positive 5/2? Then you could say it's perpendicular, because if you take the first line, you change the sign to positive, and then you flip it, right? Flip it. You take the opposite, makes it 2/5, flip it, becomes 5/2. Then you could say they're perpendicular, all right? Okay, I just want to make sure you understand. Hold on, let me go shut my door. Shh, be quiet. All right.
So wouldn't it have to be like negative So it'll be like -2/5, and then if it's flipped to 5/2, then it's perpendicular because they switched the signs to.
Yep.
Yeah, okay.
I think if I understand your question correctly, if the first line has this slope of -2/5, then the other line would have to have a slope of +5/2, 5/2, in order for us to say it's perpendicular.
Yes.
Yes, that's right.
Okay.
I'll give you another example. What if we had a line 1, let's just say that the slope of this line was -3/7. What would the slope of line 2 have to be in order for it to be perpendicular?
And it'll be like 7/3 because.
Yep, you change the sign, so it goes from negative to positive, and then you flip it, so it becomes 7/3 instead of 3/7. All right? So these two would be perpendicular. Okay. I'll let you mess with that one. All right, that's it. That takes us through. You should now be able to do the homework for that section. And we move on now to functions and function notation. Okay, so let me see where I want to start this. I think this is the preview part. Yeah. Okay, so yeah, we'll do a little preview of this. Let's talk about just functions in general. Okay, a function is a rule that assigns a value to a given input. All right, so I'm going to just draw a picture. You've probably seen this before. What we have here is what we call our inputs, also known as the domain of the function, but we're not going to get too concerned with that. And then we have the outputs, which is also called the range of the function. All right, so I like to think of functions like machines. And one example of a machine is, I don't know, a car wash, right? If you've ever taken a car through a car wash, you drive in one end, right? You put your car in neutral and you sit there for a few minutes as it takes you through and cleans your car. And then you come out the other side and you got a clean car, right? So dirty car in, clean car out. A function does the same thing. What it does is it takes a number, takes in a number on one end, takes that number through some function. So your function here, we usually represent with the lowercase f to stand for function. It takes this number in and it spits it out as a new number. Now, it doesn't actually have to be different. It could be the same. It could take a number in and spit the same number out, but most of the time it's something different. So it might take the number 2 in and spit out the number 4, or it might take the number 2 in and spit out the number 8. Every function is different, but the idea is the same. All functions take in a number and spit out a number. Now, there's some things that functions can't do, and we have to be a little bit careful when it comes to functions. This cannot happen, so this is good, but take a look at this picture. What if you have something that does this? You have a number. This thing takes it and actually spits it out to two different things. That would be like you driving your car into the car wash, right? And coming out the other side with 2 cars, right? That's not going to happen. And so this is not a function. The reason why is because we had one input, and then here we had 2 outputs, and that does not qualify as being a function. So not every single thing that we could ever think of that takes a number in and does something to it is a function. But anything that takes one number in and spits one number out is an example of a function. All right, so I'm going to try and give you an example of a real world function. Let's see, does anybody live, well, you don't have to live by yourself for this, but does anyone here have to pay for their utilities, electricity or water? Yes, okay. So let's talk about electricity, all right? So electricity, I'm going to give you this example here. Can you all hear that dog barking?
Just
Yes?
a little bit.
Just a little, okay. I'm getting
little
ready to go do something to him. It's my wife's dog. Okay, hold on just a second. I'm not going to hurt him, okay? I'll just be back.
I like how he felt the need to say, like, I'm not gonna hurt him.
Right. Clearly, he's gonna hurt the dog.
Clearly the thought crossed his mind, and I don't blame him. I understand.
All right. I hope y'all didn't hear that. No, I'm kidding. I just have to give him a stern look. All right. He'll probably keep barking though, because he's kind of not smart. Anyway, electric bill, right? So when you pay for your electricity, you have first what's called our fixed cost. Now we're going to talk about monthly electric. Oh, he's going to start barking. Your monthly electric bill. All right, so we're talking about every month. So every month when you pay for your electricity, you have what's called your fixed cost. Now this is the cost that you have every month, regardless of whether or not you use electricity or not. So even if you turn everything off in your house, turn all the power off, the electric company is still going to charge you for just having the service. Okay, just for having the service, you have a fixed cost. Now I'm going to make up these numbers, unless y'all really want me to bring up my electric bill. Just make up the numbers? Okay. I'm going to just say that this fixed cost is like $10 a month. I have no idea what it is. $10, okay? So no matter what, $10 a month. All right, now then what you have is, the next part is called your variable cost. And the variable cost is the part of it that you get charged, which depends on how much electricity you use. Now, you know, this is easier to do with water because most people can understand when you turn on your water faucet and you put 1 gallon of water in there, you have to pay for 1 gallon of water. When it comes to electricity, does anyone know what we measure electricity in? It's not as simple as gallons. The electric company measures electricity in what's called kilowatt hours. Okay, but think of it as like a gallon of water, okay? It's a measurement of how much electricity you're using. So I'm gonna make up these numbers also. Let's say that they charge 2 cents, all right? 2 cents, 0.02 is 2 cents. I'm gonna put a dollar sign in front of that so we all understand that's 2 cents per kilowatt hour. That's the abbreviation for it, kWh. All right. So this example is an example of a linear function. So let me show you how we could determine what the cost is. The cost should be equal to $10, right? No matter what, our cost is going to be $10 plus the 2 cents per kilowatt hour, right? This is where it depends on how much electricity you're using. So I'm just going to use the letter K for kilowatt hour. So does everyone see here? Like, you have to kind of squint your eyes to see this. But does everyone see that if I kind of rearrange things and relabel things, I could call cost C. And if I put the 0.02 first in front of the K and then the plus 10 behind it, does everyone see that this kind of looks like Y equals some number in front of not X? We're not using the letter X, we're using the letter K instead. And then plus some number by itself, B. Does everyone see that this is linear, right? And if it's linear, I can graph it. So what I can do is I could graph. I would start at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would put a dot here. And then my slope, right? What's my slope here? .02, right? 0.02. Now, 0.02 is a weird number to think about because we're supposed to be thinking rise over run, right? Our slope is 0.02. So I'm going to ask you to remember what these decimals mean. And hopefully you remember that this first decimal is how many tenths we have, and the second decimal is how many hundredths we have. Now, if you don't remember this, don't worry about it. I'm not going to test you on this. I want to be able to write this as a fraction. So 0.02 is the same as 2 100ths, or 2 over 100. And you could get on your calculator and check that, 2 over 100. So that means to get to the next point on my line, I need to go up 2 and to the right 100. That means up 2 and to the right 100 spaces, which can put me way off my graph. So imagine there's some point way out there. So my line is going to be almost flat. Okay, do y'all see that? It's not very steep. Now this would be the cost of having electricity, right? This would be the line that represents what's happening. Now there are a few things about this line we have to be careful with. The line actually starts here and goes this way, but it really doesn't exist over here. The reason why the line doesn't exist there is because the x-axis, this x is actually our K, and this y-axis is actually the money, right? So we can't use negative electricity. Well, unless you have solar panels. If you have solar panels on your house, then you actually you can have negative electricity because you can be pumping electricity back into the system, but we're not going to talk about that. So there it is. So that is an example of a line in a real world problem. So if you use a lot of electricity, eventually your bill gets higher and higher. I don't know if you all know this, but it's even more complicated than that when it comes to electricity. Like your bill is a certain amount. Like, you know how I said 2 cents per kilowatt hour? They'll charge you like 2 cents per kilowatt hour. But if you go over like a certain number of kilowatt hours, so like maybe you go over 1,000 kilowatt hours, then they'll up the charge to 4 cents per kilowatt hour. So the more electricity you use, the more expensive it gets. And the same thing works with water. If you use just the minimal amount of water, you're not going to pay much for it. But if you're one of these people who uses, or one of these houses that uses a lot of water, you have a lot of irrigation around your house, you have a pool, right? Then you start paying a lot of money for your water. I know for us, for our house, in the summer, we pay almost $300 a month for water. It's crazy, right? But we have sprinkler systems and a pool and all this stuff, so it gets really expensive. Okay, now how is this connected to this idea of a function, right? This thing. Well, it is a function. We plug in a value of k, and it spits out a number, doesn't it? We give it a k, it spits out a value. So this is a function. We could say in this that the cost is a function of the kilowatt hours. How much money you're going to pay per month is a function of, depends upon how many kilowatt hours you use. And so in mathematics, we have a special notation we use when we're dealing with functions, and that's what I'm going to show you now. And I'll get back to this example and show you how we'd use it here. So we have what's called functional notation, or I'll just say function notation. So I'll give you the most simple example. Let's say that we have a line, y equals mx plus b. And I think next to this, I'm going to give you a specific example. Y equals 2x plus 5. What we do is we realize that, look, if somebody gives us an x, right? If somebody were to give us a value of x, we could always figure out what y is, right? So you know, like on this example on the right, if I plug in 2 for x, I'm going to do 2 times 2 plus 5. That's going to give me 9. If I say plug in 3 for x, you're going to do that. If I plug in 10 for x, you're going to do that and get an answer. So would you all agree that y is a function of x? Would you all agree with that? The y value, what comes out, depends on the x value you plug in. So what we do is we change the notation. Okay, so this is all about notation. What we do is instead of writing y on the left-hand side, we change that over to an f and then in parentheses an x. And then we just write mx plus b. So this is just a notation change. What this is saying is that the left side of this equation, what used to be y, is a function of x, right? And so that's what this notation means. It is a function of x. Now, the way that we say this, if someone were to write this down, the way that you'd say that in words is f of x. Okay, that's the way we say that, f of x. F of x. So over here on the specific example, if I want to use the function notation, what I do is I write f of x equals 2x plus 5. And what's nice about this notation is that if I want to ask you a question now, like if I want to say, hey, what happens when you plug in 5? Here's all I have to do. I just write f with a 5 inside, and I say is equal to what? So that is me telling you to do what? When I write down f with a 5 there, what am I telling you to do?
Replace x with a 5.
Replace x with 5. So look back at this and replace the x with 5. Okay, let's do that. That becomes 2 times 5 plus 5. So you do the multiplication first. 2 times 5 is 10. Then you add 5. The answer would be 15. What if I asked you to do this? So here I'm asking you to replace the x with what? -3, right? So we do the same thing. 2 times -3 plus 5, that's going to give us -6 plus 5, which equals -1. I have a tricky one for you. What's f of t? So what am I asking you to do here?
Put a t for x.
Say again?
Put a t for x.
Yeah, replace the x with t, right? So we're going to go and replace, we're going to go 2 times, we replace the x with t, and then we put plus 5. Now this, I can't actually get a number answer, can I? My answer is 2t plus 5. That's my answer. So do you all see how this notation, this is just a new notation that we use that basically gives you the ability to tell somebody to plug a number in for x. That's all it is. Is that clear? Any questions? Now let's go back to the previous problem we were doing with the electric bill. What I could do here, okay, when we were looking at this right here, we said that the cost is a function of kilowatt hours. So instead of writing it this way, I could write it this way. C of K equals 0.02 K plus 10. So we're saying that instead of calling it lowercase f, like a function, we're calling it capital C, which represents to us cost. Cost is a function of what? This is the kilowatt hours. So our cost is a function of kilowatt hours. So if I wanted to know how much it's going to cost me if I use 100 kilowatt hours, then this is what I would write. C of 100. And that means just replace K with 100. And that's gonna turn out to be 2 plus 10. That's gonna cost me $12. So all this is just notation. That's all it is. So let's do a fresh example. Whoa, didn't mean to do that. Whoa, whoa. All right, let f of x equal 3x squared minus 4x plus 1. Okay, I have given you a function, all right? I've said, hey, everyone, this is a function. The function is f of x equals 3x squared minus 4x plus 1. This is not a line, all right? This is not a line. It does not look like y equals mx plus b. However, it's still a function. If we plug an x in, it's going to spit a number out. So here's what I'd like for you to do. I'd like for you to take the next, let's say 5-6 minutes. I'm going to give you a couple of different things for you to plug into the function, and let's see how you do with them. So the first one, I want you to do part A. I want you to do f of 0. For B, I want you to do f of 2. For C, I want you to do f of negative 2. For D, I want you to do f of, I'm gonna be mean, 1/3. Okay, let's take a few minutes, see if you can work through those. And I'm gonna put the poll up. If you finish, when you finish the first 3, okay, if you don't get to the last one, that's okay. But when you finish the first 3, click yes on the poll, all right? Okay, we got more than half of you done. I'm going to start writing the answers in here, and then you can kind of check to see that you are doing it right. Oh, hold on. I'm gonna redo the poll here. So if you got the first one right, well, you know what? Let's do it this way. How many of you got the first three right? A, B, and C? Yes or no? Okay. What was the problem? Let's see. On A, are there any questions? I think A is the most straightforward one. How about B? Anybody have any trouble with B? So then C, I guess C got some people. So remember on the -2 squared, that's -2 times -2, that's +4. So that's why I have a 4 here. And then when you do the -4 with the -2, that becomes a +8. And that's why this is +8. So I think that's the trickiest part of that one. And then the one with the fraction, that one I think probably caused some issues. Are there any questions on how I got from 1/3 squared to 1/9? Any questions on that? It's just 1/3 times 1/3. How about getting from the 4 times 1/3 to 4/3? Any questions on that? No, we're okay. That's just 4 times 1/3. I just write that as 4/1. Just multiply straight across. How about combining these two together? I did the little cross thing. You could have just put them together because they have the same denominators. Do y'all see that? They both have a 3. So I could have just done 1 minus 4 over 3, which would have given me negative 3 over 3, which would have given me negative 1, which is exactly the same thing as I got here when I got negative 9 over 9. Okay. All right. So I'm gonna put one more example up, but we're gonna work through it together. It's just gonna be a short example. So what if we have this function, f of x equals 3x minus 12. You know what? Yeah, I guess so. So here's one question I could ask, right? Like, what's f of 0? And that would just be 3 times 0, take away 12, and that would be just negative 12, because 3 times 0 is 0. We all agree with that? Part A. But here's my part B question. This is a different question. I'm going to write it down first, and then I'm going to ask us to talk about it. All right. So on part B, well, on part A, what I'm giving you is this. And I'm saying, okay, replace x with 0, right? That's what that means. But the second question is not saying replace x with 0. This is saying, when is the function equal to 0, right? That's what that's saying. When is the function equal to 0? So what you need to do here instead is you need to take the function 3x minus 12 and ask yourself, when does that equal 0? So this right here you should recognize as being a linear equation with one variable. So what we want to do with the linear equation with one variable is follow the steps. And so we want to isolate the x. We want to get the x by itself. So I would add 12 to both sides. That would give me 3x equals 12. And then I would divide both sides by 3. And I get x equals 4. So what that means is this. If we plug 4 into the function, what value should come out? Anyone?
0.
0. 0 should come out. And we could check it ourselves, but if you plug 4 in, you will get 0. Right? So the big thing here is to recognize that this right here is a different question than this right here. They are different. And so on a test, you need to make sure that you don't accidentally think that part B is asking you to plug 0 in. It's not. It's asking you to take the function and set it equal to 0 and solve it. So let me get down here to, okay, here's an example where they give us a function. They ask us to plug in -3. They ask us to plug in 0. And then what is this asking? What do we need to do to answer this third one? Is everyone clear? They give you a function. Hold on. They give you a function.
Set it to 85.
That's right. Good. Good. So this first one, we're gonna just plug that in for x, right? That goes in for x. The second one, we're gonna plug that in for x. On the third one, what we're doing is not that. On the third one, what we're doing is we're seeing when the function is equal to 85. So we want to take the original function, 9x minus 5, and set it equal to 85, and then go about solving this. I'm not going to go through it. I just want to make sure you understand what's being asked. Any questions on that? Okay. This part, they're just asking you to plug a in for x. So you'll just replace the x with a and you'll just box that answer. There's nothing else you can do because a is not a number. And then on the fifth one, they're asking you to plug a fraction in to the function. And number 6, they're asking you to take the function and set it equal to 0. So we just did a problem like that. So those are the types of questions that you're going to see. Is that all right with everyone? Yes? Okay. Now, this is where things get a little weird. Students, it's kind of interesting because students seem to do different with this. Some students are like, really get it, and they're like fine with it, and then other students have major problems with this. So what I'd like to do is start out with this idea. Let's just say that we have this function, f of x equals 2x minus 3. Does everyone agree that that's a line? Y equals mx plus b. Yes? Okay. So we could graph it. Now I'm going to be real careful with the way I graph this. I'm going to start at -3. 1, 2, 3. Here's -3. I'm going to put a dot. And then my slope is 2, which is same as 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I'm going to put a dot. And now I'm going to connect these with a straight line. So here comes a straight line. Hold on. There we go. I'm going to be off a little bit here. That's pretty good. Okay, here we go. So here's my, this is, just follow me through this and then we'll get to the next type of problem. What is f of 0? Okay, so what happens when we plug 0 into this function? So if we replace x with 0, we get -3. Everyone agree? Yes? So I want to point out that on our graph, that's this point right here. 0 went in, -3 came out. All right, what about this? What's f of 1? So let's plug 1 in. 2 times 1 minus 3. That's 2 minus 3, that's -1. Okay, so that point is actually this point. Go to the right 1, you go down 1. Does everyone see that? Right 1, down 1. What is f of 4? So f of 4 would be 2 times 4, take away 3, that's 8, take away 3, that's 5. So that's the point 1, 2, 3, 4. Here's 4, and we go up 1, 2, 3, 4, 5. That's that point right there. It's the point 4, 5. So what I want everyone to see on this is that the 0, the 1, the 4 are the x coordinates, 0, 1, and 4. And then what comes out of the function, -3, -1, 5, -3, -1, 5 are the outputs or the y coordinates, right? So the x coordinate is your input and the y coordinate is your output. Yes? Okay. Now, I'm not going to look at this right now. I'm not going to look at this at all. I don't want you to do anything with this right now. But I want you to look at the graph. Okay? I want you to look at the graph, and here's what I'm going to ask you. What is f of -1? So that means I'm giving you the input, right? And what I want to know is what is the output, right? That's what I want to know. I did that backwards. I want to know what's the output. So can someone explain to me how they're going to figure this out if you're not allowed to use the function and you're just allowed to look at the graph?
You would go to the x on the graph and then go down to where it meets the y point.
Okay, so what x value am I going to go to?
-1.
Good. So I'm going to go to the x value of -1, and I'm going to try and figure out what the y value is. So -1 on my graph is right here, -1. And then I'm going to go look on my graph, and that takes me to that point right there. And I'm going to ask myself, what's the y value there? So can you tell what that y value is?
-5.
Looks like -5, right? So that's the point, -1, -5. So the answer to this should be -5. Do you see how we're using the picture to figure out the values of the function instead of using the function to see the picture? It's reversing. We're doing it backwards. Let me do another one. I'll do this one in red. What would f of 3 be? So let me call on someone here. How about Ashlyn? Is Ashlyn around?
I'm here.
Okay, Ashlyn. Why is that not working? Oh, there, that's fine, okay. All right, Ashlyn, can you explain to me how you're gonna figure out what f of 3 is?
I'm gonna find 3 on the graph and then go up to where the line would
Okay.
meet it.
So you're gonna find 3 on the x-axis, 1, 2, 3, right? And you're gonna go up and see that point, and then what are you gonna grab from that point?
3.
3, which is the y value, right?
Yeah.
Okay, so we know that that's the point 3, 3. So when 3 goes in, 3 comes out. All right, I have one more that I want to do. This one's going to be tricky. Ready? I'm going to do it down here in the corner. Okay, so the question is right here. And let's see here. How about Leah? Is Leah here? I see Leah. Leah Gomez? No, no. How about Beth? Beth Rodriguez? All right. Let's go with Taylor Teal. Taylor, how's it going?
Good.
Good. Okay, so do you understand this question that I've posed here and how it's different than the previous ones?
So the -7, that's going to be the y value, right?
Exactly. Good. So what we're given is the y value. And your job is to figure out what the x value is. So how would you do that?
Well, I looked on the graph. And I
Good.
just plotted -7 and I saw it connected to -2.
So you went to the y-axis, you figured out where -7 was, and then you realized that that corresponds to that point right there. Yes. And then you went back up and said, what x value did that come from, right?
-2, yeah.
-2. So the answer here would be x is -2. Any questions on that? So, you know, if you look back at the last two things we've done, if somebody gives you a function, we can use this notation to ask you to plug values in for x, or we can use this notation if we want you to go find the x value that gives you this y value. We can do it completely by looking at the function, or we can be given a graph and then be asked to do the same exact thing, but just off the graph. So let's see if we can do, let's see, we have like 3 minutes left. We don't have a whole lot of time. I don't know if y'all can see that enough. Let's go for that. I'm not gonna be able to show you all the problems. Let's just look at the first view here. All right, so the first question here is what is f of 3? So that means I want to go to the x value of 3 and figure out what the y value is. So I go to 1, 2, here's 3, I go up. Here's the point, and that y value of that point is 4. Do we all agree with that? The y value of that is 4, so it's 4. Okay, let's do number 8. Here we're going to be plugging in for x, -3. So I go to -3, 1, 2, 3. Here's -3. I go up to where I have a point, and then I go figure out its y value. Its y value is what? Anyone?
1.
1, okay. All right, the next one is f of 0. So I'm going to go to 0 on the x, which means just stay right where you are and look for the graph. And the graph is straight up, and it's that dot right there. And that again is 4. The next one is -4, so we're plugging -4 in for x. So I go to the left 4, and wait a minute, doesn't my dot go right through there? Goes right through there. So what's the y value of that point?
0.
0. Good. This question sucks. Okay, this is a typo in the, oh no, sorry. I misread the problem. F of -10, we want to plug -10 in for x. That's way over here. Here's -10. Go down to my graph. Looks like the point's right there. The y value there looks like -6. All right, now number 12 is the one that's different. Does everyone see that? For what value of x is the function equal to 3? So this is kind of like what Taylor did a minute ago, and I liked her approach. She said, okay, this is the y value, right? We're given the y value this time, and we need to go find the x. So I'm going to clear everything out here. If I go to a y value of 3, here's a y value of 3. I'm going to go find the point that hits there, which is here, and I'm going to come back down and figure out what that x value is. And is it obvious to everyone that that x value is -1? Good. So x is -1. So there's a few more here that that I didn't do, but we're out of time. So in terms of your homework, okay, here's where the homework starts. You should be able to do this. Okay, they give you a function, they ask you a bunch of questions. All right, and then they give you a graph. See this graph? And ask you some questions about that graph. So 2 main concepts from this. Now don't forget, you should also finish the homework on parallel and perpendicular lines, that stuff. But for the next 2 sections, this is the homework. And that's it. When we come back on Thursday, sorry, we will do applications, which are word problems. We'll talk about the test, and then your test will be on Tuesday. And as far as the test, the material, I want to make sure that going into this, we all understand what's on here. So just to be clear, we skipped that, okay? We skipped that. So all that's going to be on the test is linear graphs, okay? So the intercept method and the slope intercept form. I told you on the test, I'm not going to care which method you use. We're going to have the idea of parallel and perpendicular lines. We're going to have functions and function notation, which is what we just finished. And then we're going to have applications. That's what will be on the test. Okay, so when we say here concept review, right, percent proportion per, we're not doing that. We're basically focusing most of our attention on lines for the test. So it's going to be a very narrowly focused test. So hopefully you understand the material. It should go well, hopefully. All right, everyone, have a good day. I'll hang out here for a minute if you have a question or something. If not, I'll see you on Thursday.
Thank you, sir.
Thank you.
Sir?
You have a question, Jesus?
Yes, sir. I just wanted to remind you about Thursday.
Remind me.
I'm going to be on.
That's right. You're Yeah, got you. So how did you, we said that we would do it where you would just take a little bit later?
Well, I'm still gonna try to see how
Do it on-
long they actually, like what.
So you still want to do it on Tuesday? You want to plan for that?
As of right now, Tuesday still works fine. I'll message you sometime during the weekend in case my plans change. But as of
Yeah.
Tuesday, as of now, Tuesday's fine.
Yeah. The main thing would be is if you're not going to take it, all right, on Tuesday, and I'll let you decide that all the way up until Tuesday morning when we start the test. Just don't come to the session, to the Zoom session, because I'm going to send the test out during the Zoom session. And so if you're there, then I'm going to assume you're there to take the test. And so I just don't want to send you the test if you're not going to take it. Does that make sense? So just, you know, if you're going to be there, great. If not, send me an email or a message or something, or, you know, just don't show up for the test, and then we'll work something out where you can do it at a different time.
All right. What?
Okay. All right. Thank you.
Thank you.